All right, starting with new faces. Is there anyone here that does not typically attend these meetings that would like to introduce themselves?
Hi, I'm Amelia. I'm an intern at VMware. I'm just a computer science major at UCF. I've been contributing a little bit, have done some pull requests to Paketo, so it's been fun.
Welcome, Amelia. We're happy to have you. All right, moving on to our next standing item, outstanding project level RFCs. Let me share my screen here. And find my other Zoom window. There we go. Okay. Starting at the bottom here, semantic versioning RFC. I think this has one of the required approvals and is waiting on an approval from Ryan. Is there anything outstanding that you'd like to talk about on this, Ryan, today?
I don't think so. I think half this meeting is going to be me apologizing for going on vacation for 2 weeks and that explaining a huge backlog of unapproved stuff.
No worries. We can
I don't think there's anything that's
outstanding.
Yeah, I went on vacation for 2 weeks and so a lot of stuff hasn't been approved in that time. I apologize. I don't think there's anything specific on that one. I just need to do one more read through and approve it.
No worries. I'm glad you weren't looking at RFCs on your vacation. Okay, up next, build pack list builders. Is there anything we want to talk about on this one today in this meeting? Okie dokie. Bill of materials.
I have nothing to add here. We're looking for approvals or any last comments people have. It's been a little bit since we've had any updates here.
Okay. We can shame myself on this one too. Throw me in there with Ryan. Get an update for you soon. Moving on to the Liberty build pack.
So I responded to a lot of the comments in the PR, and I've updated the RFC with based on those comments. So I'm looking for more comments.
Sounds good. We can go through this one again. I was just reading through some of these before the meeting, but I've not made it to the end yet. Thank you for the responses and the updates.
Thank you for the comments.
Is there anything that while you're responding to them you wanted to talk about while we're here, or is it just we should do another pass?
Yeah, let's do another pass. I don't really have any update.
Cool. Okay, moving on. This is not an RFC. It is an implementation of our RFC to move team level RFCs to this repo. Does not move the RFCs, but it sets up a scaffolding and permission structure that would let teams move their own RFCs. So once this is merged, sub-team maintainers, be aware that you should move your RFCs and check off your team in the issue that Ryan created to track which ones we've moved. Up next is the reloadable process types RFC. This was submitted by Paul Warren, who is also a VMware employee. I wonder if he knows when this working group meeting is. I don't know if he can make these meetings, but I'll take the action to make sure that he is aware of when they are in case he would like to make them to come talk about this. But I did talk with him about this a little bit in advance, so I can speak to some of the details here and do my best to answer any questions that folks might have on this. The general summary is that this proposal would introduce a new utility build pack called the Watch Exec build pack. And this proposal also proposes a new conventional configuration, environment variable configuration called live reloadable, where if it's true, a build pack contributing a process type should contribute a live reloadable version of that process type that would allow for basically updates in a dev container without stopping the process. Not every language ecosystem would be encouraged to use Watch Exec utilities. Like, for example, if Spring Boot DevTools is available, that can provide a better interface for live reloadable process types for Java developers. But this utility build pack would allow for language families to include this utility and then use it when creating process types if there was not a more idiomatic way to do it in that language ecosystem. So this sort of touches every language family. So if you all haven't read through it yet, I would encourage you to. Does anyone want to ask questions or share thoughts on this before we move on?
The one thought I had was like, if I remember right, with the tilt and scaffold, when used with Docker files, they like rebuild on like changes to the the file system. Like if you change the source code on the fly, but with build packs, I don't think they rebuild, and it's just copy into the thingy. So like languages that need build, like C# kind of .NET or whatever, probably the start command of the succeeding build pack will have to also like do the build. But like something like Python or whatever, which is like on the fly interpreter kind of languages, that could work, I think.
I think the intention here in this first pass is to, if someone had a solution for rebuilding and copying in changes, to unblock them by allowing the process to be restarted. I think eventually it would be a goal. I know it's a goal in the CMB project to sort of come up with a acceptably fast partial version of a build pack build that would allow you to generate a diff and copy it into a container before running. This is just addressing the like, how do we restart the process after a diff is copied into the container? But I think that's okay because it still unblocks a lot of use cases. Like if someone is writing a tilt file for a compiled language that when the local version of the source code changes and then gets compiled and they copy that compiled artifact in, at least allowing our containers to be restarted in this way would unblock these workflows, even if it doesn't sort of magically address all potential concerns.
Sounds good.
Cool. All right, if we don't have any more questions on this one, can move on to add licenses to dependency server.
Yes, this is mine and Forrest's RFC. It's pretty light. It supersedes a different RFC that I believe Marty and some other folks had put in when they set up the dependency server, which just laid out all the different fields that they wanted to include with each dependency's metadata. So this RFC is just to propose that we start publishing license metadata there. So you can just see that we just want to add that one field, which will be an array of licenses. Types,
this
license
is the
types.
SPDX license identifier.
Yes, and that can get used in like either CycloneDX or SPDX bill of materials formats.
Awesome. This seems valuable. So everyone, I think this just came in recently. Take a moment to read through it and approve.
Thank you.
Okay, I think that gets us through our project level RFCs. Moving on to the language specific RFCs. We still just have this one WIP RFC on .NET Core. I think in the last working group meeting, we said that this wasn't ready for eyeballs yet. Is that still the case?
Yes, unfortunately.
No worries, just checking. Okay, that is it for RFC Roundup. Which brings us to the rest of our agenda. First up is maintainers for dependencies and stacks. I copied this down from the featured topics, so I'm not quite sure who the original author was, but if you're here, please kick us off.
Yeah, I threw this on here so I wouldn't forget to bring it up. We're starting to do some work on our dependency server, and I realized that we have no maintainers specified. So the current thing that we'll do is just push to main, because there's no one to approve PRs specifically. And we also have no one designated for our stack repos that we now own. So I was just wondering what the plan forward is, and if we need to find people to nominate to be maintainers, or what that will look like.
I think I'd prefer we didn't push directly to main, and that instead we unblock the maintainership approval process. I think the issue now is that the two maintainers that are on there are effectively no longer involved in the project. I know Marty is on paternity leave for some long period of time, and then Kenny is working on stuff related to KPAC and other things in the CMD space, but not really Buildpacks. So I think we could still at least get a vote from Kenny, and then I think we could probably have one of the steering committee members stand in as a proxy vote for the second maintainer, to vote in maybe a couple more maintainers for those particular teams, so that we have folks who can review and merge PRs.
It's a bit strange, because I believe when Marty ended up being the last person who was a maintainer and contributor over there, I think they removed the need for any maintainers or anything, because obviously there was nobody to approve his PRs, and he was the only person doing any work on it. So I don't think they went through the official process to remove Kenny as a maintainer. So I guess he probably is still technically one, but we should double check on that, because I'm not entirely sure what they did with that.
As far as I could tell, looking at the teams this morning, it looked like he was still a maintainer. So I think he still has voting privileges as far as it stands today. But I think that would make sense is for us to nominate a couple of new maintainers. We can hold a couple of votes, one to add those maintainers, and another one maybe to move the existing maintainers who aren't going to be involved in the short medium term into an emeritus status for the time being. The last thing is reinstate any of the branch protection rules that may have been removed, so that Marty could merge his own PRs.
Perfect.
That all sounds reasonable to me.
Do you need anything from me or anybody to get the ball rolling on finding maintainers?
Seems like the question is, who of the folks that are involved in the project or have interest in being involved in the project know the most about stacks and dependencies and can demonstrate their capacity to maintain them. So it would be great if someone wanted to self-nominate for that, but if they don't, I'm sure Ryan and I will go find someone.
Sophie, you can either nominate yourself or I will nominate you. Those are your options, but I think either way, you're probably going to become a maintainer. If you want to find a second person.
Yes, sounds good to me. I'll file an issue on that repo to nominate myself.
Congratulations on your new stacks and dependencies. Up next, wildcard stack for more Buildpacks. Sam.
Yeah, this, I think I had a conversation with some of the Paketo maintainers on the Paketo Slack around this a while ago, but I don't think anything came out of it. So in all the build packs in the Paketo world can roughly be divided into things that provide dependencies and then build packs that use the existing dependencies and like binaries on there to do some configuration, like shell out and call these binaries with some flags and do some things. So this is more for the latter set of those build packs. Like currently there's nothing preventing them from supporting a wildcard stack, which is essentially any stack as long as it's Linux. I still don't know how the wildcard stack works between different operating systems, but I'm assuming that it has the ability to differentiate between Windows and Linux.
Yeah, I think in the CMB spec, that's sort of like a gap, but the fact that build packs get packaged for either Linux or Windows, I think makes it so we could treat it as all Linux, not all everything.
So given that it's all Linux, it's a safe assumption that all of the build packs that fall in this latter category, given that they're written in Go, should be like runnable and supportable on all Linux stacks, unless I'm wrong. And if that's the case, like putting that on there would definitely increase the reuse that these build packs get across other, like with other stacks or other projects. And I think that also sort of like the whole reason that this is not one monolithic build pack and it's divided into separate build packs is to allow for more reuse and for allow other people to swap in like the binary build packs with something that's compatible with their operating system would reuse the configuration logic. So that's where I'm coming from.
Can I ask a clarifying question? I'm a little bit rusty again on the specifics of stack IDs in the build pack specification. So I'm like pulling it up and reading the definition of what a stack ID must be. It has to be unique. It can only contain numbers, letters, and then the special characters dot, slash, or minus. And it should not use reverse domain name notation to avoid name collisions. I guess the question I have here is, what is this wildcard build pack? Is this like a special case that's been outlined somewhere?
I thought it was in the spec. I don't know if it's in the spec, but it's definitely in the RFC. And I think the platform API 05 implements it, where if you put a asterisk there instead of like a proper valid stack ID, it would match against any stack.
Is there an open issue, Emily, to like include that information in the build pack specification? That's like also you can use a wildcard.
Yeah, I just linked the RFC. Let me find an issue. There should be an issue.
I think that's just something that we hadn't been tracking. The other thing is like I had heard rumblings that there was a conversation about like semi-wildcard stack identifiers, things along the lines of being able to say like, rather than us saying like our current, Ubuntu stack identifier, it would be like something like ubuntu.linux.buildpacks.io. And then you might be able to say like star.linux.buildpacks.io. I have no idea if anyone's made any progress on that front.
No, we haven't. Like we discussed it. I was sort of gung ho on that idea, but folks brought up some good points around the fact that, you know, if we needed more levels of granularity there than just saying there'll be exactly this many fields and certain ones can be wildcards is not very extensible. So there's a desire to solve that same problem, but differently. And there's, Sam and I actually talked about some options there, but there's no concrete proposal yet. It's got parked behind some other things.
Yeah, I think I mean, that would still be useful for certain binary build packs, I believe, where like if you have a binary or like certain stack, I don't know how stack packs would fit into this, if they even would. But for like the config build packs, wouldn't it, as they currently are, wouldn't it still be better to have like a wildcard stack for them?
Yeah.
Better in the sense of reusability. I don't know so much about the maintenance overhead. I don't know if that would be better or not, but yeah.
So I did find the spec issue in PR. I think the crux of the problem here is that our specs are not very well normalized. So I'm imagining, Ryan, that you were looking at the platform spec and where it describes stacks there. There is a PR that made changes to the Buildpack spec.
Yeah.
That was in Buildpack API 05.
Okay, I think the issue was I was on the Buildpack spec, and then I got to this Buildpack implementation section where it says each stack instacks either, and then it outlines it and includes a ID must be set to a valid stack ID, which then links to the platform's definition of the stack ID, which does not include any reference to wildcards.
Yeah, right under that it says it or it must be a wildcard. But yeah, once you follow the link, if you didn't read the or, it's not great. It's not great. I'll admit that.
A valid stack ID. I think, yeah, I don't know. I would have just included the wildcard definition as this is a valid stack ID indicating any.
A build pack does not necessarily have to like have a stack descriptor at all, right? If it's pretty generic, it's running a command and which could be same on all platforms, then probably we should, you know, have the good practice of them not really limiting to a particular stack.
I think that is what the wildcard stack is for. It is not valid to just totally omit stacks. That's essentially the same as saying I don't run on any stacks versus all stacks. And the build pack doesn't run on any stacks. It's not making sense in the ecosystem. So it's a required field. This whole area could use some improvement. I think that's evident. I'm interested in Sam's suggestion that build packs that sort of contribute processes, ones that aren't installing things, could run on any stack. Sort of thinking about some examples here. So let's take the Java build pack, the Paketo Java build pack, which, you know, runs JVM applications using the JVM. Right now, without changes to the tiny stack, this does not work on the tiny stack because the JVM fails because it needs libc, which is not available on the tiny stack. This Java build pack is composed of different components, right? And I'm sort of like interested in the question of which one of those components we think is incompatible versus compatible. Is it like the one that installs the JVM is incompatible because it's installing something that can't run on the tiny stack, but the one that creates the process type is compatible. It gets into a weird place then when like you might have a build pack that installs a JVM at build time, but then, you know, another later build pack, like the Java native image use case, compiles it down to a native image that can run on the tiny stack. So it's a build pack that could run on the tiny stack at build, but not at runtime, right? Like, I'm not exactly sure where you would draw the exact line of which components are compatible in which cases. Does that make sense as an example?
I'm not that familiar with the Java world to understand that specific use case where your build time can run on the tiny stack, but runtime can't.
It's because for us, the tiny stack has a much more extensive build image than the than run image, right? And because you can sort of define differences like that in the very hand wavy, a stack ID can be any contract you want it to be. You know, there are dependencies that a component can install that could be used successfully at build time, but couldn't be used successfully at runtime. So in some ways, you would want those components to say they could run on either the tiny or Bionic stacks. It would only be the build pack contributing the process that's like at launch time, you're going to run at launch time, you're going to run java-jar. Like, that's the thing that's not compatible with the tiny stack, which is sort of like, I think, the opposite of the suggestion you're making.
Yeah. I didn't think of it that way. So for me, build pack being able to run is it being able to just run the build or detect binary appropriately without error codes during the image build part. I didn't think about the launch part or how that would affect things. I would assume that like whatever is calling like so whatever is providing the JVM binary, should that be incompatible there? Like if you can provide a standalone JVM binary that includes libc, what's stopping it from running on the tiny stack?
I think in general, the JVMs it provides don't statically link libc, so they wouldn't run on the tiny stack. But there are cases where that build pack might be providing only a JDK for use at build time, and then you compile down to a native image for runtime, and then during that compilation, you've statically linked in libc. So like the build pack is compatible with the tiny stack, but it depends on which of like the couple options you're using it for. I think in general, we're a little bit erred on the wrong side of this stack compatibility debate, where we work really hard to make sure that you can't run something that might break. Instead, in the process, we've prevented some things from running that could succeed. I would like to consider sort of like rebalancing that, where we're more optimistic about what could succeed, and we understand that part of the trade-off is depending on how exactly people use those components, they might run into an error.
So there's nothing stopping that build pack from validating other things before it contributes that process, right? Like stack IDs is like relying on the platform itself to just say no.
Yeah, and the build pack itself could say no based on the stack ID. Like that's provided to the build pack in the contract. So we could fail at that point. It's sort of like, I think at one point there's a lot of concern that no one should be able to waste their time setting up a build or making a build there if it will never run. But I think maybe that concern is a bit overplayed, and we can move that kind of validation into the build pack if it truly detects that something isn't going to work in a more dynamic way rather than relying on these exact strings being present.
I mean, if in the build pack detect or build phase, what you're doing is just checking the stack ID environment variable and comparing it against values, like, no, I would not assume that's the sort of validation you want to do. But if it's doing something more dynamic, like looking at the existing dependencies provided by other build packs, looking at other environment variables which decide whether it gets compiled to that native image or if it's just running through the JVM, then it could decide to fail or not. So that's a more dynamic case of it succeeding or failing, rather than just saying outright, no, this is a stack ID I don't support, I'll fail regardless. I think we should be doing the latter rather than just completely delegating it to stacks the way they currently are to say no. If they're more expressive in the future, I think it makes sense to reevaluate. But the way stacks currently are, I feel it's sort of wrong to just omit an entire class of stacks just because one of the other things may be missing, which you could check for anyway.
I'm pretty convinced by that. I'm curious what, like most of my experiences in Java or with the sort of really generic utilities that should work anywhere. I'm curious what folks working in some of the other language families think. Like, do you feel like you have components that this applies to?
I mean, no, go ahead.
Oh no, I was just gonna say that I can speak about Node.js npm. I can speak about Python and Go mod for all three of these use cases. The current like pip install build pack that's in Paketo community, the Go mod vendor, and the Go build pack, and the what am I missing? NPM install build pack. Like all three of these would just work, given that they have the right pip binary, Python interpreter, npm binary, and Node, and the Go binary. So those are three languages. I don't know about others. I would imagine Ruby works similarly to Python.
I think that really increase our case for modularity, which we claim is a thing. It's like, yes, we're not going to like put time into making sure we build an npm binary or download one to run on said platform. But if we have a different build pack that executes npm, and then folks who want to put the effort into maintaining dependencies for that stack, could use some of our logic. Like, I feel like that would be fulfilling the promise of the modularity.
Like if you look at some of the decisions that go into like just configuring all these random package managers to work with the Buildpacks layout, that's a lot of logic people end up rewriting. Like if you look at, for example, the GCP Buildpacks where they configure Python, they have like this huge comment explaining why they pass certain flags to pip the way they do, and I would rather just like reuse that as a separate component. Like right now it's all bundled into one build pack, so I can't. But I would just reuse that part of the configuration logic rather than write my own, which I think Paketo does it already. Like it provides separate build packs for all of these things. Might as well make it more reusable.
I guess the question is, how do we make this actionable? Do we want to write up an RFC that outlines the expectation here, or do we want to just open up issues against Buildpacks that we identify as being reasonable to mark with a wildcard stack identifier? Like, I think what you're outlining, Sam, is pretty reasonable. I think part of the reason this hasn't happened yet is like the Paketo or only maintains one stack up to this point. So for us, from our standpoint, it's like, well, we only maintain Ubuntu Bionic really, and like, you know, derivatives therein. So we haven't really thought about what this means for, you know, folks who are working on top of other stacks or building their own stacks from scratch. So the use case seems completely reasonable. I guess the question I have is, how do we turn this into something that actually makes forward progress beyond this conversation we're having here?
I think this runs into a weird problem that happens with Buildpacks, especially if you want to put one in each repo, where it seems trivial enough that I wouldn't say it's the kind of change that we need an elaborate RFC for, right? It's like, I think this could be done in issues. I also think saying, Sam, open an issue on every single component that this could possibly apply to, you know, is possible. And maybe Sam's a good person, he would do it for us. But it seems like sometimes it'd be nice to have a place to just open a global issue, or we can make a checkbox for each language family, and then maintainers could go through and create issues for the specific components that they think it applies to.
I think that's reasonable. Like, we could do that on the RFC's repo. We have stuff that's similarly like that already, I think.
Yeah, maybe we can just start that as a practice where that could be a place for global issues that sort of track many smaller issues.
The only reason I see for an RFC is if you want to codify the process of identifying these Buildpacks and proactively labeling them as wildcard with wildcard stacks in the future. And also, like, there are certain like classes of Buildpacks that would always be, I assume, would be like wildcard, would have wildcard stacks. Like the utility Buildpacks should all ideally have wildcard stacks. I don't know of a utility Buildpack that requires a specific binary right now, unless I'm missing.
I would also lean toward an RFC. I wouldn't want to put the burden of writing an RFC on you, though. So I was willing to take an issue. But I do like the idea of codifying this decision in an RFC, something that we can point to in the future to say, here is a minimal expectation we have about a particular kind of build pack, and a build pack that's getting built anew would need to like meet that expectation.
A third option, I'm very happy with the RFC. If we want to do that, happy to go forward with that. I think the third option is we do have this style guide in Paketo Buildpacks community that we haven't really used. Like, is this the kind of thing where it'd be like a PR to a style guide would be a way to codify this as a new shared expectation?
I'd be happy with that as well.
All right, Sam, if you want to do one of these things.
Choose your own adventure.
Yeah.
I would go with the style guide simply because that seems like low effort. And it still achieves the same purpose as an RFC. Then I guess we can create like a common issue to track the migration of all of the config Buildpacks to the wildcard stack. Cool.
Cool. All right, I think that's it for our agenda today. Does anyone have any late breaking topics? All right, requisite uncomfortable silence over. All free to go about your day. Have a good one.